Our solar system is a fascinating collection of planets and celestial objects interconnected by gravity, with the Sun at its center. Within this vast system, we find a variety of celestial bodies, such as moons, dwarf planets, asteroids, meteoroids, and even comets. Let's explore all this and discover the peculiarities of each planet, their fascinating orbits, and understand how our solar system fits into the vast universe. Speaking of planets, our solar system hosts 8 of them: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The solar system has an incredible history of 4.568 billion years and is located in our galaxy, the Milky Way. If we start counting from Pluto's distant orbit, the solar system extends for more than 5 billion kilometers. The closest planetary system to our solar system is Alpha Centauri, located about 4.37 light-years away. Proxima Centauri is the closest star to our Sun, approximately 4.22 light-years away. Now, our Sun is a true giant. To give you an idea, about 1 million Earths could fit inside it. Analysis of its light reveals that this immense star is predominantly composed of hydrogen and helium, with a small percentage of other elements. The Sun's core is a nuclear fusion reactor, constantly converting hydrogen into helium, generating the light and heat it radiates into space. Our star and the entire solar system probably originated about 4.6 billion years ago, when a cloud of matter condensed. This matter may have originated from ancient supernova explosions. Although the Sun is neither the largest nor the brightest, it is extremely important for life on Earth. It is a medium-sized, stable, and relatively young star, located in one of the Milky Way's spiral arms. Although common in the galactic context, its existence is fundamental for life on our planet. Now, speaking of the planets, they are divided into 2 categories: inner and outer planets. The inner planets include Mercury, Venus, Earth, and Mars, all rocky and smaller in size. The outer planets, such as Jupiter, Saturn, Uranus, and Neptune, are gas giants and formed farther from the Sun. This density difference is due to the formation conditions in their regions. As we move away from the Sun, temperatures decrease, allowing different substances to form. Near the Sun, only denser elements could condense, resulting in rocky planets like Mercury, Venus, Mars, and Earth. On the other hand, farther from the Sun, where temperatures were lower, formation was dominated by ice, creating gas giants like Jupiter and Saturn. The separation between these 2 groups of planets is marked by the asteroid belt, where debris from a planet that never formed due to Jupiter's gravitational influence is scattered. But what happened to Pluto? For a long time, Pluto was considered the 9th planet in our solar system, until in 2006 it was reclassified as a dwarf planet due to its orbital behavior. The main reason was that Pluto doesn't meet one of the criteria to be considered a planet. It doesn't clear its orbit, meaning it shares its space with other similarly sized objects in terms of size and gravity, like its moon Charon. Now, this is just an introduction to our fascinating solar system. Each planet has its own unique characteristics that we'll explore in detail. In this illustration, we can visualize the orbits that the planets follow around the Sun. Now, let's explore the striking features of each of these fascinating worlds. We'll start with Mercury. This is a small planet, slightly larger than 1/3 of Earth's size, and is the closest to our Sun. When observing its surface, we notice rocky formations, similar to the Moon's, as shown in captured images. A unique feature of Mercury are the lobate scarps, suggesting the planet is shrinking over time. Additionally, Mercury shares some similarities with our Moon, including chemical composition, the presence of ice at its poles, and numerous impact craters. Occasionally, we can spot it from Earth, usually just after sunset or in the early morning hours. Venus. In terms of size, mass, and chemical composition, Venus is surprisingly similar to Earth. However, its dense atmosphere prevents heat from escaping, creating the famous greenhouse effect that causes Venus's surface temperature to reach over an incredible 400 degrees, close to lead's melting point. Venus's atmosphere is predominantly composed of carbon dioxide, with traces of other gases, such as oxygen. The atmospheric pressure on Venus is about 90 times greater than on Earth, and wind patterns are remarkably complex. A notable detail is Venus's rotation around its axis, which takes about 4 Earth days, although the planet itself rotates extremely slowly, with a Venusian day equivalent to 243 Earth days. Despite its dense atmosphere, Venus is poor in water today, although the abundant presence of deuterium suggests it may have had water in its distant past. Earth. The third planet from the Sun is our home, Earth, being the only one known to harbor life. Earth is positioned at an ideal distance from the Sun, allowing for conditions favorable to life. Additionally, it has a protective ozone layer, extensive liquid water masses covering about 75% of its surface, and a robust magnetic field. Unlike other rocky planets, Earth has a relatively fast rotation. Our atmosphere is primarily composed of nitrogen and oxygen, with small amounts of other gases. It is stratified and gradually becomes thinner as we move away from the surface. A unique feature of Earth is the presence of tectonic plates, which result in constant surface changes over geological timescales. This means evidence of craters, common on other planets, has been erased. Earth features a wide variety of landscapes, including mountains, plains, and deserts, as well as an abundance of water, both in the form of oceans and surface and underground freshwater. The Moon, our natural satellite, exerts a notable influence on Earth, mainly through tides which play an important role in terrestrial life. The Moon rotates in sync with Earth, always showing us the same face. Mars. Now we'll focus on Mars, which is slightly smaller than Earth and Venus, but still larger than Mercury. Its surface displays a reddish hue due to the abundance of iron oxides. For a long time, Mars has sparked people's curiosity, leading to speculation about the possible existence of intelligent life. Mars's atmosphere is thin, mostly composed of carbon dioxide, with traces of other elements such as argon. There is no appreciable amount of water vapor or oxygen. Oxygen, when present, is generally found in rocky compounds. Mars doesn't have its own magnetic field, meaning solar wind particles directly hit its surface, which is barely protected by the thin atmosphere. Mars's landscape is varied, and there is evidence that in the distant past, the planet had liquid water. One highlight is Mount Olympus, the largest known volcano in the entire solar system. Its height surpasses Mount Everest by 3 times, and its volume is 100 times greater than that of Mauna Loa, Earth's largest volcano. Due to the lack of tectonic activity and low gravity, lava accumulated over time, giving rise to this colossal structure. Jupiter. Now we turn our attention to the giant of the solar system, Jupiter, unquestionably the largest planet in terms of size. Its diameter is about 11 times greater than Earth's, and its atmospheric conditions are extreme. Jupiter is known for its turbulent atmosphere, with powerful winds cutting through it. The famous Great Red Spot is a long-lasting storm, with winds reaching speeds of up to 600 kilometers per hour. Jupiter is predominantly gaseous, without a solid surface. However, as we delve deeper into its atmosphere, pressure increases and gas becomes liquid. Its rapid rotation results in flattening at the poles. Although most of Jupiter is composed of hydrogen and helium like the Sun, its interior contains a hot core of heavy elements. This is evidenced by the infrared radiation the planet emits, indicating very high internal temperatures compared to the surface. Jupiter has its own magnetic field, which is about 14 times stronger than Earth's. The planet is also notable for hosting a large number of moons, including the 4 Galilean moons, Io, Europa, Callisto, and Ganymede, the latter being the largest moon in the solar system. These moons, with unique characteristics such as water, volcanism, and extreme weather, are fascinating worlds in their own right. Saturn. Saturn is unmistakable due to its complex ring system, first observed by Galileo in 1609. These rings are composed of millions of ice particles, possibly remnants of ancient moons and comets that collided with the planet. Some of Saturn's satellites, known as shepherd moons, play a crucial role in maintaining the ring's orbit and defining their regions in the planet's equatorial plane. Saturn has a peculiar shape, being an oblate spheroid due to its low density and rapid rotation. In fact, it is so light that it could float in a hypothetical ocean of sufficient size. The deformation in its shape is also influenced by latitude-dependent rotation variations and interactions with its moons. Saturn's internal structure is similar to Jupiter's, with a gaseous mantle and a hot core of heavy elements. The Voyager, Cassini and Ulysses missions provided data supporting this conclusion. Uranus. Now we turn our gaze to Uranus, a planet with peculiar movements. Its rotation is retrograde, similar to Venus's, and its rotation axis is highly tilted relative to the orbital plane, at an angle of 97.9 degrees. As a result, Uranus appears to rotate on its side, creating extreme seasons that last an impressive 21 years. Uranus's blue-green coloration is due to methane in its atmosphere, which is much colder than Saturn's or Jupiter's atmospheres. However, its internal structure remains a mystery. Uranus and Neptune are considered ice worlds, composed of gaseous and liquid elements. Although Uranus doesn't generate metallic hydrogen due to its lower mass and pressure, it has a significant magnetic field comparable to Earth's. Uranus also has its own ring system, though less spectacular than Saturn's, being faint and difficult to see from Earth. Its discovery occurred in 1977 when the planet passed in front of a star, temporarily obscuring it and revealing the rings. Like other outer planets, Uranus has a variety of moons, including Oberon, Titania, Umbriel, Ariel, and Miranda, names inspired by the works of Alexander Pope and William Shakespeare. Frozen water has been detected on some of these moons. Neptune. At the edge of the solar system lies Neptune, the farthest planet from the Sun. Its discovery resulted from observations of unexplained gravitational perturbations that suggested the presence of a large, unidentified object. Seen from Earth, Neptune appears as a small blue-green dot, and until recently little was known about its structure. It was only with the Voyager mission in the late 1980s that we began to better understand this planet. The images revealed a surface with signs of violent storms and fast winds, including a large spot similar to Jupiter's Great Red Spot, called the Great Dark Spot. Neptune's atmosphere is rich in methane, and the planet also has a ring system, though less impressive than Saturn's. Its internal structure consists of an icy crust covering a metallic core, and the planet has its own magnetic field. As for moons, approximately 15 have been identified so far, though there may be others waiting to be discovered, as Neptune is located at a great distance and remains largely unexplored. Among the notable moons are Triton and Nereid, also known as Neptune Dessau, with Triton being a moon with a retrograde orbit and its own thin nitrogen atmosphere. Beyond planets, our solar system hosts other fascinating astronomical objects, such as dwarf planets, moons, comets, asteroids, and meteoroids. Each has unique characteristics that deserve our attention. Dwarf planets. In the vast space between Mars and Jupiter, and beyond Neptune's orbit in the region known as the Kuiper Belt, many objects exist that, according to astronomical criteria, don't qualify as planets. Among them, the most notable are Ceres. Located in the asteroid belt, it is the largest object in this region. Pluto. Previously considered the 9th planet in our solar system, now classified as a dwarf planet. Eris. Discovered in 2003, Eris is larger than Pluto and orbits farther from the Sun. Makemake. Located in the Kuiper Belt, it is about half the size of Pluto. Haumea. Also in the Kuiper Belt, it has a notably ellipsoidal shape and is accompanied by rings. The fundamental criterion for differentiating them from larger planets is both their size and the gravitational pull they exert due to their mass. To be considered planets, an object must orbit the Sun, have an approximately spherical shape, and possess sufficient gravity to dominate other bodies in its vicinity, either as satellites or as part of the planet itself. Ceres, Pluto, and Eris don't meet these criteria, leading to the creation of the dwarf planet category, which Pluto joined in 2006. In the distant Kuiper Belt, there may be more dwarf planets awaiting discovery. Moons, larger planets, and even Pluto have moons orbiting them. There are over 100 moons associated with the larger planets, most of them around the outer planets, while the inner planets, like Earth and Mars, have only 3 known moons: Earth's moon and Mars' Phobos and Deimos. There may still be future discoveries, especially on planets farther from the Sun, like Neptune and other ice giants. These moons come in various forms, ranging from spheroidal to highly irregular, the largest likely formed alongside their host planets, while others may have been captured by gravity. There are even temporary moons that, for various reasons, are temporarily captured by a planet, but eventually escape its influence. Besides larger planets, other celestial bodies, like those mentioned earlier, also have moons. Comets. Comets are remnants of the cloud of matter that gave rise to our solar system. Composed of ice, rocks, and dust, they primarily reside in the more distant areas of the solar system. However, periodically, they approach the Sun. Astronomers believe there are 3 extremely distant regions in the solar system where most comets reside: the Kuiper Belt, the Oort cloud, and the scattered disk asteroids, centaurs, and meteoroids. Asteroids are rocky bodies smaller than dwarf planets or moons. Most of them inhabit the asteroid belt, a region marking the boundary between rocky and gas planets. Centaurs are so named because they share characteristics of both asteroids and comets, an analogy to the mythological half-human, half-horse creatures. Discovered in 1977, they haven't been well photographed yet, but it's known they are abundant between the orbits of Jupiter and Neptune. Finally, a meteoroid is a fragment of a larger object, like those described so far. They can be as small as a particle of matter, not quite as small as a dust grain, with sizes ranging from 100 micrometers up to 50 kilometers in diameter. Conclusion. At this point, we can reflect on the immensity of the cosmos and how even within our own solar system, there are countless stories to be told and discoveries to be made. As we continue to explore space, we remember that we are part of an ever-expanding universe, full of wonders that challenge our imagination. The solar system is a window into the vastness of space, a humble reminder of our place in the universe, and an infinite source of inspiration for human curiosity. May our quest for knowledge and exploration never cease as we continue to unravel the mysteries of the cosmos, united by our curiosity and passion for exploring the unknown. We hope this video has been helpful to you. If you have anything to add or any video suggestions, please share them with us in the comments section. Like and share the video. Subscribe and follow us on our social media, whose links are in the description below. And remember, knowledge is an investment with inexhaustible returns.